Hello everyone. I'll be talking about how to improve the performance of order by limit queries in MariaDB and what has been the history of order by limit queries in both MariaDB and MySQL. I work as a optimizer developer in MariaDB Corporation. I've been involved in the company for the last 3 years almost. So let's start. So now this part would be the history, and then I'll talk what is new in MariaDB 10.5. So to handle order by limit queries, what are the ways which we can do it? One thing is that we use an ordered index. The ordered index can be used in 3 ways. You could have a ref access where you could have some key part equal to constant, and then with the remaining key parts the rows would be ordered. Something similar would also happen with range scan, and with index scan you cannot have with index scan you cannot have an equality, so it would just be a normal index scan on the index. Second case would be file sort. File sort would have 2 ways how we have it. Either you sort the first table and then do the join with the remaining tables, or you put the entire join inside a temporary table and then sort the temporary table. So this is the first case that we will use with an ordered index. So the records from this table would be ordered by the order by clause if the index can resolve the order by clause, and then you perform the join with the remaining tables. The important thing is, while doing the join, you cannot use join buffering. An example would be because join buffering breaks the ordering. So you have to make sure that join buffering is disabled. Second would be if you have a descending clause in the order by clause, then you have to make sure that descending is for all the key parts of the index that is mentioned. Also, with this approach, you can shortcut the join execution. You don't need to compute the entire join. You can stop as soon as you get the number of records mentioned in the limit. Now this would be the second case where you sort where you apply file sort on the first non-constant table. So here you read from the table T1 and pass it to file sort, and then you read the output of file sort and then perform the remaining join. Yeah, so it is almost similar to how we have with an ordered index, that you can, again, you cannot use join buffering. Another important thing would be any condition that is dependent on the first table would be computed before sending the output to file sort. To see if this approach is working in explain, for example, you will see using file sort in the first column of the first row in explain. And again, this is also another way in which you will be able to shortcut the execution with limit, because the rows would be ordered already. Now this comes the third part, where we try to perform the entire join first and then put the records inside the temporary table and then pass the temporary table to file sort, and then we get the ordered output. To apply the limit, you cannot shortcut the join execution. You have to compute the entire join, and then only when you do file sort, then you can shortcut the execution of file sort, that you just, as soon as you get the limit records, you tell the file sort to stop and you are done. With this case, there is no issue with using join buffering, or any type of join order is not allowed. But the main drawback for order by limit queries is that limit cannot be applied beforehand. You have to compute the entire join, and only then you can apply the limit. So this could be very inefficient for smaller limits. And in explain, the first row again shows using temporary, using file sort, which means that you are using temporary table and then doing file sort. Now, what all we do we currently not have in the order by limit optimizer? We currently don't take the cost of sorting. Limit is not taken into account, and the only way in which we are able to shortcut the join execution is after a join order is picked, we check if a use of an index can be done to shortcut the join execution, or if there is something like equality propagation you could do so that you could just file sort by the first table that you picked by the join order here. But the join planner doesn't take limit into consideration. These are all the things done after the join planner has picked the join plan. So here is an example. We have a order by a particular column on which we have an index. The join optimizer picks a strategy where we use to compute the entire join and then do file sort, which has an execution time of 25.2 seconds. Now if I try to force a particular join order using straight join, then you can see that here tfact is using an index on column 1 to do the join execution, and the execution time is like 30 milliseconds. Yeah. So if the join optimizer had any idea that with this index we could shortcut the join execution, we could have come up with a better execution plan. Now here is another example where you have again order by T0.d, but you don't have an index on this column. The join optimizer again picked an approach where it was using temporary table plus file sort. Now if I try to force the join order, now in this case it's using file sort on the first table, and again it's because it's using file sort on the first table, the output is ordered. It can just go ahead and shortcut the execution as soon as it gets the limit records. No need to compute the entire join again. Now what is new in MariaDB 10.5 is we are coming with a cost-based optimization where the join planner would take into consideration both the cost of sorting and the limit. So motivation wise, both pushing the limit and cost of sorting, and again the main thing that I have been emphasizing, we want to shortcut the join execution for limit. So to consider the limit, we try to push the limit. Now how the limit is pushed is we try to find a join prefix that can resolve the order by clause. That's the prime condition, that you can sort the prefix with the order by clause, and then you can just push the limit. Yeah. So inside the join planner code, we apply the sort operation here, and then we push the limit. So how is push the limit calculated? So what exactly is meant by push the limit is you find a prefix by which ordering can be resolved, and then the records in the prefix, when you push the limit, you will only read a fraction of those records, and this fraction is how we consider by taking limit into account. So this is the prefix which can resolve the order by clause. This is the total join cardinality, and then you have limit. So this is the number of this formula would give us the number of records that we would read from the prefix that can resolve the order by clause. And yeah, let's go ahead. So to push the limit, first you need the estimate of join cardinality. So we run the join planner once to get the estimate of join cardinality currently. Also you have access methods like indexes that I was talking about that already have the ordering that have already all the records ordered. So these are also considered during the join planner stage. Now this will be a bit technical. So for each join prefix, you have two conditions. If that prefix can resolve the order by clause, you can either push the limit at that very instance, or you can extend the prefix by another table and then push the limit. Why do we do this? Is we want to consider all possible plans where we can push the limit. Also, equality propagation. Earlier, equality propagation is always done after the joint planner has picked the plan. Now, equalities are propagated before. So, if you have a join prefix like this, T2, T3, and you have an order by clause by T1.A, and there is an equality. So, we would consider pushing the limit both after this plan and after this plan. So, the equalities of the where clause are propagated and considered by the join planner. Now, how does the join execution work? So, as soon as we have a prefix that can resolve the order by clause, we try to materialize the prefix and put the records inside a temporary table. Then we sort the materialized table with the order by clause, and then from the output of file sort, we start reading one by one, and then we join with the remaining tables. And again, the execution again stops as soon as the records are found. So again, by this we are not computing the entire join. So this is how the execution path exactly looks. You have tables in the prefix, you materialize the result and put them inside the sort nest. Join buffering is allowed for all these parts because these are coming before we are performing the order by clause. Plus conditions, the conditions that are dependent only on these tables are checked beforehand, rest are attached to the later tables. So the sort nest you have, you send the records to file sort, and then you start reading file sort's output and join with the remaining tables. Again, now it is similar to the example where we had file sort on the first table and then we were doing the join. So again, no join buffering is allowed over here, and the execution will stop as soon as the limit records are reached. So here is an example where we will be using a sort nest. So you have an order by clause on two tables. So if you see in the explain, it shows a sort nest here, which is a materialized result of nation and customer table. And so this is, and then you can see that we are applying file sort on the sort nest. Another interesting part is if you look at this condition, for orders tables, it will not know anything about the customer key. So it needs to refer to the fields of the sort nest and not of the base table itself, because the base tables are now not at all over there. They are all referring to the sort nest table fields. So this was one of the examples that I was demonstrating earlier, where I was showing the limitation. So we have again the same case where we have a key on column 1, and this was earlier using temporary table plus file sort, but after this optimization it's able to use an index on column 1 to do the join execution, and it provides a 1900x speed up for this case. Also, here is another query where with the DBT3 dataset which I created here. So again, the execution time, which was picking temporary table plus file sort earlier, is now picking an index to do the join execution and shortcutting the join execution as soon as the limit records are reached, and again providing a significant speed up. So the most important part for the optimizer to pick any plan is the selectivity of the conditions. this approach that MariaDB has taken for order by limit optimization heavily depends on the selectivity of the conditions. So if someone wants to use it, I would suggest at least use histograms to provide the selectivities to the optimizer, because if otherwise the estimates can vary a lot, and when we push the limit, then that can give us plans that are not that good. Also, another limitation is that you have few predicates for which selectivity is not known. So what we try to do is we predict the selectivity as 100%, but we have discussed internally in the team to maybe add some penalty for such cases, because if this condition is highly selective, then using a sort nest or using this new optimization can be harmful for us. And again, this part that the estimate of joint cardinality are very pessimistic. We over predict everything. So again, when we push the limit, then our estimates can be very optimistic instead of being pessimistic. Yeah, that's all. Thank you. Questions? Yeah.
So one problem with this order by limit queries and the attempt to shortcut the evaluation when you get a limit is that if there's some kind of correlation between the order by column and the columns of your where clause, you risk that you don't find any of the interesting rows in the first part of the scan. So you actually have to use less efficient query plan, and which is really the basis for the using. And the rows do not appear until very late. So we actually, the worst case for this plan is actually worse, much worse than a plan that did the sorting afterwards. Do you have any idea of how?
No, I didn't get the complete question. Can you repeat the question?
So if take an example, for example, you order by a date.
Yeah.
Descending to get the newest one. But the where clause is so that only old rows qualify.
Yeah.
Then you actually would have to go through a lot of joining of the new rows, and you'd find no one that qualifies for the where clause. So actually, using the index, you would have for the where clause actually.
No, but the where clause would be evaluated beforehand, before you do the order by clause, if the tables are inside the sort nest.
Yeah, but in your case, you show that you have the where clause on order that was after the sort nest.
Yeah. For that case, you have it may be the case that the conditions you have in the sort nest more rows, and then when you are joining with the remaining ones, you are not finding enough rows to match. That may be an overestimate, yes. But if you give the optimizer the right selectivity estimates, I think so it can make a smart decision and maybe include the orders table inside the sort nest.
But you don't have any estimates on the correlation between the columns.
Yeah, if for such cases, then I don't think so this optimization would work that well. Yeah.